Good afternoon, everyone. Myself, Dr. Taslima Ahamad, Associate Professor from EC Department. Today, I am going to give my lecture on classification of computerized process control. This topic is from the subject Computerized Process Control. Slide again is on. Yes, firstly, I will give introduction about this subject, and after that, I will give a brief description of this topic. Firstly, you see the introduction part. The introduction part mainly describes the introduction of computer-based different process system. As we know that in everyday life, we are using different types of items, elements that are mainly based on computer and computer control system. That's why that is a very important topic to describe in our basic examples. After that, we will see the architecture of computerized process control, then human machine interface. Firstly, here we see the different outcomes after studying this topic. The first outcome, understand the role of computers in process control, elements of a computer-aided process control, and classification of computer. After that, the second outcome is design phase lock loop, different mixers, time division multiplexed system. Then the third outcome is realized process model, physical model, control model, and modeling procedure. The fourth outcome is formulate of cascade control, predictive control, adaptive control, inferential control, intelligent control, and statistical control. The fifth outcome is design an electric oven temperature controller or reheat furnace temperature controller. Actually, how nowadays the computer control process we are using, that is the main part of this topic. Everyone know that before 2000 the electric oven system does not use the automatic control system, but after that computer system invent, and we using different types of microcontrollers for handling this type of system. For this subject, the unit 1 mainly covers these topics: basics of computer-aided process control, role of computers in a process control, element of computer-aided process control system, then classification of computer-aided process control system, after that architecture. Based on connection of computers, we are dividing the architecture of a computerized process control into different types. As for example, centralized control system, distributed control system, hierarchical control system. After that, economics of computer-aided process control. Then benefits of using computers in a process control. And after, lastly, the process interface, because without interfacing, we cannot give input data and we cannot obtain the output data from a system. Therefore, the different process interfaces are analog, digital, pulse, and standard. Then unit 2 covers the most important part, industrial communication system, communication networking, industrial communication system, data transfer technique, then different types of softwares, application, system support software. That are the different parts of unit 2. Then real-time operating system. Then unit 3 part mainly comprises of process modeling for computerized process control. As for example, a process model, physical model, control model, then modeling procedure. As we know that for our third year and final year student, we all are making mini project or major project. And for that, we have to require firstly the theoretical knowledge. Without theoretical knowledge, we cannot define the output of a system. Therefore, the goal or definition. Firstly, we have to define what we have to do. That is the main aim or goal of any process. After that, definition. Because in theory, always we study the mathematical expression of any topic, any system, any process. Therefore, the different process, how you can do a work, that is defining by this modeling procedure. Then information preparation. For that aim or goal, we are defining the system. Then we have to know the previous result about that system and what is the different advantages after doing this process, that we have to prepare. After that, model formulation, then solution finding, because if any error comes after testing the equipment, then we have to find different solution about that error. After that, result analysis, then model validation. When model will valid? When the previous result, that means the theoretical result and experimental result is similar, then you can say that your model is valid. Then unit 4 part, that comprises the cascade control system, predictive control system, adaptive control system, then inferential control system, intelligent control system, and statistical control. After that, the unit 5th part. As I explained already about this, how you can model a particular system. And here we are taking the examples: electric oven system, reheat furnace, or thickness and flatness measuring of any roller. And related to this topic, you can refer this book also. Firstly, the introduction. What is the main purpose of any system using computer, and what are the different techniques we are using here? That are, firstly, I already explained what is the role of computer, that is the part of study. Therefore, I am focusing on this topic. The Industrial Revolution has contributed largely in the development of machine-based control, where machines in process industries were took over the world done by human physical power. The early production processes were natural scale versions of traditional manual practices. The industrial process control has modernized with different modern industries. Process control is therefore not a discovery of recent past, but is rather as old as industry itself. The engineer and designers of process industries always try to automate the process as much as possible. Thus, the need of better instrumentation and automatic control become the dominant reason for better operation of industrial processes. The role of computer, how you can use the computer, that is firstly given by Brown and Campbell in their paper 1950, and they given a particular block diagram definition of a particular process. Because where we have to use computer, when computers invent, no one did not know about the process, how the computer can help. Nowadays we see the condition of our COVID-19, when we start the online class also, that is possible only due to computer. That is the best example nowadays in our process system, because before that in educational system there are no use of computer for studying as normal classes. And during this session we see that through computer, by using different software, we can do also online classes, and that is very helpful for us for understanding any type of topic. For that, here we see the basic block diagram. Firstly, we have to given a raw material input to any process, and for defining the input we are requiring some amount or quality of the input, and proper measurement of the input is required. For that, the computer gives some command for how much input we have to give for the particular process. Therefore, the input part is also connected to the computer. After that, we getting the result, and result we have to compare. Always we know that when we make a process or when we define a system, the output should be compared with the theoretical value or the previous value, because without comparing we cannot say that our process is a valid model. Therefore, the feedback loop is also controlled by the computer, and different appropriate parameters are also controlled by computer. Therefore, the computer is centrally used in this process system. That is, we are using in our measuring system computer controlled, that is our parallel interface model IEEE 488.2. And here we see the measuring system, how computer is used. Is used as a measuring device controlling the output, that is we are seen in the oscilloscope, and that value on that signal we are transferring to our PC system for any filtration purpose. We can make IR filter, FIR filter. We can design the filters for the resolving our noise problem in that particular signal, and after that we can transfer that particular signal. First, we see the direct digital control used in the different computer system, and that is the example. And here we see the first used computer overview, that is the architecture system consists of ferrite core memory storage system, and that is example of direct digital control. Now you see the different point of role of computers in measurement and process control. The first one is development of digital computer technology has increasingly used for measurement and control application. Point number two, the basic objective of computer-based measurement and control is to acquire information from different field devices and compute a logical decision to manipulate the material and energy flow of given processes in a desired way to get the optimal output. The expectations from a process computer compared to the general purpose computer is primarily in terms of response time, computing power, flexibility, and fault tolerance. The other difficulties that is encountered for a process computer is to provide a solution to the problem of complexity, flexibility, and geographical separation of process elements. Like that, digital computer control applications in the process industries may be passive or active. Passive application involves only acquisition of process data, whereas active application involves acquisition and manipulation of data also. Here we can see the block diagram of direct digital control system. Here we control the equipment or data acquisition system directly by using the computer, that is the server computer and that is the client computer, and that both are controlling by a computer process system. And here we are using the application softwares for controlling different functions. The major application of digital computers in the process control is optimization, because we want a correct output and we want to use low cost for a process. That's why we are using the digital computer system in any process. The advantages of computer control have motivated many, and that variation we can also view by using different types of use of instruments, knobs, and switches instead of our keyboards and screen. The basic components that we are seeing in computerized process control, that are firstly one is measurement and data acquisition. After that, data conversion and scaling. Then data accumulation and formatting. Last one is visual display and then comparing. First we see this is the example of block diagram of hot air blower system, and here we can see the system is controlled by computer totally, and for that we are using analog to digital converter, then digital to analog converter for obtaining the data, And here we have required to use temperature sensor. We can use temperature sensor here LM35 for controlling the temperature, maintain that particular temperature of the heater. And we can also say that a thermocouple is also using as a temperature measuring equipment here. Already I have explained the architecture, that is centralized, distributed, and hierarchical. Now you can see this classification as a application. The early digital based control has the following drawbacks: low speed, very small memory size, programming done in machine language, then different knowledge is also required in computer technology, limited knowledge of suppliers, no maintenance support, then poor reliability. The centralized computer-based process system comprised of large computer system with huge space and power-consuming type magnetic core memory. But the system is very expensive due to high cost. To justify the high cost, every possible control functions, including both supervisory and direct digital control, that is using central or mainframe computer. The use of centralized computer control system has a problem of providing expensive communication system. Then come the distributed computer system. The distributed computer system means we divide the function of a system into different computers, and by that we can divide the function also, and we can control the function properly. Because in centralized system, if the center computer have any drawbacks and it may be damaged, then whole system you have to shut down. Therefore the main advantage of distributed is that the function is divided into different parts, and we can handling one function when in another function if there is any problem. That's why that is also used in nowadays in field instrumentations. Hierarchical system, that always we are also doing in this pattern. As for example, top management give us different information, and we have to follow that rule and regulation from the hierarchy. As for example, here we see in bottom level, level 0, that is production process, level 1, that is function of sensor and actuators, and that is controlled by from where level 2, automated process control, and after that the automated process control, that is mainly maintained by manufacturing operations management, and above there is business planning and logistics. Always in higher industries, and nowadays we are following this pattern because we are governing some rule and regulation from the higher authority. Now see the different classification, that is batch process and continuous process. What is batch process? That is one sequential process that is defining from year by year by using simple sequence of a system. Then continuous process. Continuous process is another hand referring involving some work with a particular time being, and there is no sequence, we cannot break that sequence. That's why it is known as continuous. And we can see here a small block diagram that describes how you can use the sequential or logical control system. And that is the example of that system. We are using a control system to a water heater, and we are maintaining the temperature level, and that is a continuous process. And after that, we also see here the classification as a part of study, and here we see the diagram production management control, and that production management control is controlled by the equipment control in both direction, because we have to control the quality of the product, and we also see that product is required or not required for human being, and according to that we are using the sequential process. If that product is not required in that situation, we have to change our logic. Therefore, logic control is very important, and that is controlled by our computer. And also we have to focus on safety interlocks, because different equipments are controlled by the different process, and that process using some security system. That's why we have to see this safety interlock also. That example I am describing here, continuously controlled water to water heater, because the input variable, that is control voltage, and that voltage source providing a particular range, and that range is given to the water heater system, and there may be different disturbances, and that disturbances is environmental also, and noise may occur that we have to control. And that for that we are making some software based program, so that the disturbances cannot be occur in the system. Therefore, the disturbances is also modeled by using computer, and the output is temperature controlled. And in the second example, continuously using, in this system we are controlling the water level, because we can measure water level of any tank continuously, and that is a continuous process, because we have to see the level of water. And for that also we are using different types of level sensor, and that level sensor continuously work, and according to that the valve of the system will open or closed. Therefore, we have to show that particular process, and the disturbances occurred should be also redesigning or modifying according to our system. Therefore, we see the use of computer in a process control, and we are getting the classifications as according to architecture, that is centralized, distributed, and hierarchical, and according to process it is batch process or sequential process or continuous process, we can name it as. And we see the different classification as also based on the computer system, because computer software is also using we here, and therefore there is also classification of computer system, that is system applications, different types of softwares, system support softwares, and application softwares, that are also classification of softwares used in a computer system. And that is batch process, continuous process, and this process also gives some examples, and we can also compare these three types also according to different functions, and we fulfill this particular point by using these three process. As in centralized we are using the computer in the central system, and in distributed the whole function, whole process is divided into small parts, and we can make some management system for that particular distributed system and the hierarchical system. Main advantage and main the point fulfill in case of hierarchical system, because hierarchical system follow a particular path, and according to that path we are describing our system. As for example, in this system, the level 5, that describing mainly the business planning, that plan the different rules to govern the system. As level 0, that is the lowest level, that is the field automation, and is installed for measurement of process parameters. This level would forward the measured value to level 1 for process control function. If that system does not provide the data, then we cannot handle the system. Therefore, in every level is interconnected, and we are seeing this hierarchical system is the most important part of this system, and therefore we are following this hierarchical system for any controlling of a process. Nowadays we are getting different classification, but nowadays we are using hierarchical system. That is most important part. And for our students, if they are making their project, they also provide this different types of process like this, because when you decide a project, you are mainly following this procedure, because your project guide gives some guidance, and according to that you are doing your job. Okay, therefore the monitoring and control part is in level 1, and at level 2 the supervisory functions are implemented, because in level 2 we are getting the data collection, logging, then process optimization. The mathematical model of the process efficiently take care of overall optimization. Then level 3, that mainly define the plant level, where functions such as plant resource allocation, production planning and scheduling, then maintenance scheduling, production accounting, that all are explaining. Therefore, the level 0 is connected with level 1. Without level 0 we cannot go to level 1. Then level 1 is connected with level 2. Without that level we cannot go to the above system, and the rule and regulations are maintaining from level 4. Therefore that is the main classification of computerized process control, and its importance we are seeing here. And from this class, we can summarize that hierarchical control system from the classifications is mainly used in industry nowadays, because without this system, we cannot follow a path. And this system mainly using and gives a rule or regulation or describing of a system. Therefore, we follow this hierarchical computer control system. And the different types based on this is batch process and continuous process. An example that is given: controlling of water level, temperature of water heater, that is already explained. And from this we can conclude that that is a very important topic nowadays for controlling a process, and we are using as a electronics student microcontroller based different systems, and that also follow this computerized process control, because without computer we cannot interface our microcontroller, because the programming part also we are doing in computer. Therefore the use of computer in everyday life is very important, and it is applied. Thank you to all.